We are to calculate the molar mass. Calculate the molar mass of the following substance. Now, when you are calculating for molar mass, you make use of the mass number given to you alongside with the what, the number of what, atoms. Are you getting me? So in the question we are giving the various what, mass number for each of the elements. So for the first one, we are giving LiCO3. Now it's very easy. You'll be multiplying the number of atoms with the word mass number, then you sum up everything. Are you following? And this is a bonus question. So from here, what's our lithium? Lithium is how many? 7. It's sitting at 7 times how many lithium do we have? 1. Then plus carbon is how many? Carbon is how many? That's 12 times how many atom? 1. Oxygen is how many? 16. That is 16 times what? 3. So from there, 12 times 7 times 1 is what? 7. Then plus 12 plus what? 16 times 3, 48. So add up everything. What do we have? 67. That is 67 gram per mole. So number 2, we are giving Na2SO4. Now sodium is how many? 23. That's 23 times 2. Plus sulfur is how many? 32. That is 32 times how many atoms of sulfur? 1. Then plus oxygen is how many? 16. That is 16 times 4. So from there, 23 times 2, 46, plus 32, then plus 64. So add up everything. What do we have? 142 gram per what? Mole. So number 3, we are giving KNO3. So what the mass number for potassium? 39. That 39 times how many atom? 1. Are you following? Nitrogen is how many? 14. How many atom of nitrogen? 1. Nitrogen 14. Nitrogen is 14. It's a mistake. Nitrogen is 14. Then plus oxygen is how many? 16. Times what? 3. So 39 times 1, 39, plus 14, plus 16 times 3, 48. So add up, what do we have? 101 gram per what? Mole. Please hope you are getting it. So number 4 of it, we are giving H2SO4. Now hydrogen is how many? 1 times 2. Plus sulfur is how many? 32 times what? 1. Then oxygen is how many? 16. 16 times 4. So 1 times 2 give us what? 2. Plus 32. Plus 16 times 4. That's 64. We'll add up everything. 98 gram per mole. So let's take the last one. We are giving Na2CO3. Sodium is how many? 23. 23. How many atoms of sodium? 2. Carbon is how many? Carbon is how many? We have 12. Then how many atoms? 1. Then plus oxygen is how many? 16. How many atoms of oxygen? 3. So 23 times 2, 46. Plus 12 times 1 is 12. Plus 16 times 3, 48. So if you add up everything, so we have it to be what? 106 gram per what? Gram per what? So that's your final answer. So you can any question is equals to the molar mass of the elements all over molar mass of the compound times 100/1 is expressed in what? In percentage. Hello. So this percentage composition by mass. Now for this we are asked calculate the percentage composition by mass of each of the elements in the what? In the compound below. So we are given triazonitrate 5 HNO3. Now when you are calculating percentage composition by mass, first thing you do, you calculate the molar mass of the compound. Are you following?
Yes, sir.
You calculate the molar mass of the what? Of the compound. Now from here we are given their mass number for each of the what? Element. Are you following? Now to look for the molar mass of the compound here, hydrogen is 1, right? How many atom? 1. Nitrogen is 14. How many atom? 1. Then oxygen is what? 16. How many atom? 3. So 1 times 1 is 1 plus 14 plus 48. If you add up, what do we have? That is 63 gram per mole. So this is the molar mass of the what? Of the compound. Now sometimes they might ask you to look for maybe the molar mass of nitrogen present in the compound or the percentage composition by mass of oxygen present in the what? Compound. But this time they didn't specify. Instead they ask us to calculate for what? Each of them. Now you look for that of hydrogen, the percentage of hydrogen, the percentage of nitrogen, and the percentage of what? Oxygen. If they ask to look for just oxygen, you look for what? Oxygen. Are you following? If they ask to look for just nitrogen, you look for what? Nitrogen. Is that clear? All right. Now to look for that of percentage of hydrogen. Now hydrogen here is just H, is it not? Then all over HNO3 times 100/1. Are you following? And the nitrogen here is just 1, right? That's 1. What the molar mass of it here? 63 times 100/1. Are you following? 1 times 100 is what? 100 over what? 63. 100 divided by 63. 1 point what? 587 what? Percent. So you also look for percentage of what? Nitrogen. To look for nitrogen, nitrogen is there is just N, is it not? Then all over what? HNO3 times 100/1. Are you following? So the nitrogen here is how many? 14. Then HNO3 is how many? 63 times 100/1. So from there we have it as 14 times 100. 1400 divided by 63. 1400 divided by 63. 22 point what? 22%. All right. We also look for percentage of what? Oxygen. So percentage of what? Oxygen. And oxygen here is what? O3. Oxygen there is what? So we have 3 atoms of oxygen all over HNO3 times 100/what? 1. And O3 is sitting as what? 48. That is 60 times 3. Are you following? We give us what? 48. All over HNO3 is how many? 63. Then times 100/1. So 48 times 100, 4800 over what? 63. 4800 divided by 63. 76 point what? 19%. So to check if you are correct, are you getting me? You can add up everything together if it's up to what? 100. So if you sum up everything together, it should be up to 100. Are you following? If it's not to 100, you know that what you did is what? Wrong. Even though sometimes you might have like 99.99999, approximately what? 100 is still correct. So the other maybe you now having something like maybe 90 or 80 something. You don't know that there is error in what you did. Are you following? So you have to cross check your work. So number 2, we now have to look for that of what? Na2CO what? 3. So we have Na2CO3. What do you do first? You look for the what? Molar mass of the compound. Are you following? So the molar mass of D, that is 23 times 2, then plus 12 times 1, then plus 16 times 3. 23 times 2, 46, plus 12, plus 48. So if you add up, what do we have? 106 gram per what? Mole. Then we are asked to look for the percentage of each of them, right? So look for percentage of sodium. Sodium here is what? Na2. Are you following? All over Na2CO3 times 100 over 1. Are you following? Yes, sir. So from here, our Na2 is sitting as what? 46. That is 46 over 106 times 100 over 1. 46 times 100 is what? 4600 divided by 106. What do we have? 43.39%. We also look for percentage of what? Carbon. So percentage of what? Carbon. So carbon here is just what? C, right? That's C over what? Na2CO3 times 100 over 1. So percentage of carbon will be, what's carbon there? It's just 12. So we add 12 over 106 times 100 over 1. So percentage of C, 12 times 100, 200. 106 times 1, 106. So if you divide, what do we have? 11 point what? 32%. Then the next one, we also look for percentage of what? Oxygen. Oxygen here is what? O3, right? Yeah. Oxygen in the compound is what? O3. So we have O3 over Na2CO3 times 100 over 1. O3 there, that is 60 times 3, give us what? 48. So that is 48, then over what? 106 times 100 over 1. 48 times 106. That 4800, then over 106. So what do we have? 45.28%. So number 2 question there. We are now told that what is the percentage by mass of oxygen in what? Copper 2 oxide. If you observe in this place, we are only looking for what? Just oxygen in this compound. Are you following? And we are giving copper 2 oxide, that's CuO. So we have to look for molar mass of copper 2 oxide, right? Copper is how many? 64. So here we have 64 times 1. Plus oxygen is what? 60 times 1. 64 times 1 is what? 64. Plus what? 16. So what do we have? That 80 gram per what? Mole. So we are now asked to look for the percentage of what? Oxygen. Are you following? So to look for percentage of oxygen now, so we call O over what? CuO times 100 over 1. Are you following? So oxygen is there is how many? That is 16 over what? The compound 80 times 100 over 1. So 16 times 100, 1600. So we have 1600 divided by 80. 1600 divided by 80. That's 20. That's 20%. All right. So the B part of it, this is not percentage by mass. Hope you know that. So this very question is under what? Mass mole relationship, right? All right. For this now, we've done something like this before. They say calculate the number of what? Of mole of what? CO2. All right. The B part. So we are looking for what? N. Is it not? Which is the number of mole of what? CO2. All right. CO2. Okay. So this time around, there's a present in what? 2.20 gram of the what? Substance. That's mass of the substance, right? So we're giving our mass to be what? 2.20 gram. And some people will be like, okay, for us to look for n now is mass over what? Molar mass. You say, they didn't give us molar mass. You can get your molar mass. Is it not molar mass we were looking for, the one we did before? This is how to look for molar mass. Are you getting me? Since you are giving a compound, definitely you can get your molar mass from there. Are you following? Now, since we are giving CO2, so carbon, you can see they give you the mass number for each of them. Carbon is how many? 12 times 1 plus oxygen 16 times 2. So 12 times 1 is what? So we are giving 12 plus 32. We give us what? 44 gram per mole. So this time around, our N will be equal to mass over molar mass. So from there, what was our mass in the question? What was our mass? 2.20. That's 2.20 divided by what was not the molar mass? What was the molar mass? That's 44. So this time around, our N 2.20 divided by 44. 0.05 what? Moles. Please, all the workings are clear. Yes. All right, so you can copy that. So move to balancing of equation.